Hi everyone, this video deals with the process of fossilization and fossils. Fossils constitute an important tool not only in the study of the evolution of life on Earth, but overall the geological past, as they can deliver a lot of information regarding the environment in which animals lived. Let's talk today about the process of fossilization and the resulting type of fossils. I hope you enjoy it and don't forget to like, share, and subscribe. Fossils are the main component of what we know as the fossil record. They give us a glimpse of the evolution of life on Earth and the geologic past. They are the remains or traces of prehistoric life and are commonly associated with sedimentary rocks. The scientific study of fossils is called paleontology, and it combines both geology and biology in an attempt to understand all aspects of the succession of life over the vast expanse of geologic time. Thus, they are useful not only in paleoenvironmental interpretations, but they also help us to understand the evolution of life and can be used correlating rocks of similar ages located over vast distances. Fossils are of many types and include also fossilized human remains. Similarly to humans, some can be relatively recent and may preserve delicate parts such as tissues and may not have been altered at all depending on the conditions of preservation. Examples of fossils are teeth, bones, and shells that are commonly found in sedimentary successions. In some cases, the conditions of preservation are quite unique to the point that entire animals, including their flesh and internal organs, are preserved. Although the common belief is that fossilization is the norm, it is rather the exception. For any organism, whether animal or plant, to be fossilized, an exceptional set of conditions are required. The evidence is the fossils themselves, and by studying them we can get information of the type of processes that promote fossilization, and that in turn can serve as the basis of the type of fossils that we can find. In some instances, fossilization preserves the entirety of the remains of prehistoric animals to the point that we can even see what their last meal was. This is Dima, a baby mammoth found frozen in the Arctic tundra of Siberia. Herein, fossilization is so good that we can find all sorts of hard and soft parts preserved. This provides not only anatomical information of extinct species, but also tell us about their physiology and how they interacted with their environment. For fossilization to happen, a set of special conditions and processes are required. Perhaps the most commonly known of these processes is permineralization. It happens when mineral-rich groundwater permeates porous tissue such as bone or wood, where minerals precipitate out of solution and fill pores and empty spaces. This type of fossilization is easier to grasp because they are tangible remains and we can imagine the environments of the particular animal or plant that is fossilized. Take this one for example. The formation of petrified wood. It involves permineralization with silica, often from a volcanic source such as a surrounding layer of volcanic ash. The wood is gradually transformed into charred, sometimes with colorful bands from impurities such as iron or carbon. The word petrified literally means turned into stone. Sometimes the microscopic details of the petrified structures are preserved in such a high level of detail that is easy to confuse with remains from a recently fallen tree. The preservation of details is such that we can even see the wood grains, so it is easy to imagine that this is an old tree that has been petrified. However, there is another type of fossils that are quite common and that in most cases are easy to relate to a particular animal or plant. These are mold and casts. When a shell or other structure is buried in sediment and then dissolved by underground water, a mold is created. This is particularly well illustrated in the case of shells of ancient animals composed of calcium carbonate. Following dissolution, in most instances, the mold left behind reflects only the shape and surface marking of the organism. Note that in this case, the mold left behind does not reveal any information concerning its internal structure. If given the right conditions, these molds could subsequently be filled with any other material resulting in the creation of a cast. Fossils are of many types. The remains of relatively recent organisms may have not been altered at all. Far less common are entire animals, flesh or other soft parts included, that have been preserved because of rather unusual conditions. For instance, mammoths that were frozen in the Arctic tundra of Siberia and Alaska are examples of such unique circumstances. Also, animals preserved in tar or boggy conditions give us a unique glimpse of this type of preservation. Another way to preserve delicate remains, for example, of soft-body animals and leaves, is impressions and carbonization. In this case, fine-grained sediment acts as a host and encases the remains of an organism. As time passes, pressure increases due to burial and lithification, squeezes out the liquid and gaseous components and leaves behind a thin residue of carbon. For example, certain types of black fissile mudstone known as shale, deposited as organic-rich mud in oxygen-deficient environments, often contains abundant carbonized remains, as dysoxia and anoxia lead to better preservation. If the film of carbon is removed from a fossil preserved in fine-grained sediment, a replica of the surface of that particular fossil may remain. In this case, it is called an impression, and it may still show great detail of the organism. Preservation in natural resins such as amber is another unique and fascinating way in which fossilization occurs. This is due to the fact that commonly, soft-bodied, delicate organisms such as insects are difficult to preserve, and compared to the big vertebrates, for example, they are relatively rare in the fossil record. This is because they have to first overcome the natural decay following death, and also they must be protected from any pressure that would destroy them. Thus, one way in which some insects have been preserved is in amber. Amber is produced by the hardened resin secreted from ancient trees. The tree secretes a sticky resin that seals off the insect from the atmosphere and protects the remains from any potential damage from the surrounding environment. The resin itself forms a protective case, a sort of pressure-resistant capsule, leading to the preservation of such soft, delicate parts. In addition to the body fossils, there is a significant number of other signs of organism behavior in the rock record that constitute traces of prehistoric life. We call them trace fossils. Examples of such indirect evidence of life on Earth include tracks, burrows, coprolites, gastrolites, etc. These are not the body of the animal itself, but is rather a trace left behind as the organism interacted with its environment, including any substrate where they live in. Why do we say that fossilization is not the norm, but rather the exception? Because when an organism perishes, its soft parts commonly quickly get rotten, dismembered, transported, decomposed by bacteria, eaten by scavengers, etc. This is particularly true in tropical environments or settings with abundant fauna or a dynamic environment. Occasionally, however, the remains are quickly buried by sediment. The sediment in this case acts as a protecting case that keeps safe the remains from any of the destructive processes in the surrounding environment. Thus, in this case, rapid burial favors preservation by providing a quick protecting safety area against normal decay or damaging processes operating in the depositional environment. What we call the fossil record is actually full of gaps. Due to the unique set of conditions required for fossilization, only a tiny fraction of the organisms that have lived during the geologic past have been preserved as fossils. Normally, the remains of an animal or plant quickly decay or are destroyed. So, the question is, under what circumstances are they preserved? Two special conditions appear to be necessary. Number one, rapid burial, and number two, whether the organism possesses or not hard parts. In addition to the environmental conditions, animals and plants have a much better chance of being preserved if they are made of hard materials compared to their soft-bodied counterparts. Soft tissues usually decay so rapidly that preservation is the exception and not the norm. Hard parts such as shells, bones, and teeth predominate in the record of past life. Perhaps the most popular among these examples are dinosaur skeletons, shark teeth, and ammonites or any other shelly fauna. Because preservation is contingent on special conditions, the record of life in the geological past is biased and contains many gaps. Thus, organisms with hard parts and that lived in areas of sedimentation are much more abundant than their soft-bodied counterparts. On some unique occasions, like in the Burgess Shale or the Ediacaran fauna, we get a unique glimpse of the beginning of complex life forms, even if they were soft-bodied organisms. However, despite the unique set of conditions in these cases, likely the vast majority of other life forms do not meet the special conditions favoring preservation and constitute gaps in the fossil record. In part, based on the observations made on fossils, we can have a record of the apparition and evolution of life on Earth. We can study how populations decline, evolve, or even how animals recover following mass extinction events. So because fossilization is the exception and not the norm, next time you see a fossil, think about the unique set of conditions that are required for that to happen and marvel at one of the records of life on Earth. And that is indeed quite an incredible thing. Thank you for watching up to this point. I hope this video contributes to increasing your admiration and amazement for our planet and the life in it throughout its history, and that is now part of the fossil record. Please let me know in the comment box what is your favorite type of fossilization process, and more importantly, why? About myself? Well, I like when the remains of an animal are preserved in tar or boggy conditions. Why? Well, because in such environments, the low levels of oxygenation allow for such an exquisite preservation of details, including soft tissues. And I think that that's quite amazing. And you? Please let me know in the comment box and I will do my best to answer all of them. Don't forget to like, share, and subscribe. And I will see you in our next video. Ciao!